Hey everyone, my name is Patrick and I'm a PhD student at the Institute of Geo-Hydroinformatics at Hamburg University of Technology. In this video, we want to give you an introduction on soil sampling. We explain the basics to planning, tools and techniques that you can apply when sampling your soils. We will try to give perspectives both for sampling of single fields or a small number of fields for research or agricultural purposes, but also speak about concepts for soil sampling campaigns covering a large number of sampling sites, possibly across countries and continents. Today's video is aiming to be an introduction and will not be sufficient to cover the complete planning of a soil sampling campaign, all the tools and all the techniques. In this introduction, we will explain the basics and show you how to sample topsoil in a depth of up to 20 centimeters. However, your requirements may be different and every soil sampling project can have very specific requirements. To guide you toward the optimal solution for your particular project, we will therefore mention literature, international standards and further resources that you can use as a reference. So let's start with planning. Usually you should start by planning the scope of your soil sampling. Let's begin with some questions that you can already start thinking about before walking into the field. What is the number of fields and sampling sites? Do you want to sample your private garden? Do you want to sample one or a handful of research sites or fields used for agriculture? Or do you actually plan to sample many sites, potentially across regions or even countries or continents, to then compare the results? Depending on your scope, the tools and techniques you choose may differ. You should also already have an idea about how many samples you want to take per site. What is the sampling depth that you are interested in? Is it the topsoil of around 20 centimeters, like we are showing you in our examples today? Or are you interested in deeper soil horizons, which might need specialized tools? Another important question to answer early is who is performing the subsequent analysis of your soil. Do you have your own research facilities and laboratories? Or are you working with an external lab or company? If this is the case, you should inquire about the prerequisites. What is the amount of soil they need for the desired analysis? And how do you pack and label your samples for transport? One last consideration should be if you expect to find pollutants or contaminants, or are specifically sampling to find them, because then extra caution might be required. So then, let's speak about timing. You want to sample the soil in a steady state, representative for the conditions that plants, animals, fungi and microorganisms commonly encounter in the soil. Sampling is therefore usually done between spring and autumn. In winter, soil conditions are not representative for the growing season, and soils might be frozen, and just in general, sampling soils in low temperatures might be less fun than on a sunny day. Do also not sample right after fertilization or right after tillage if you don't intend to investigate the state of the soil specifically following these events. To reach a common soil state, the soil will need some time to process the disturbance caused by fertilization and tillage. If you plan to repeat measurements, for example yearly, you should plan to always sample around the same time of the year, preferably always close to the same date to allow for a comparison over time. Okay, so the last topic that we want to cover for planning is related to the scope we talked about earlier. And the bigger question is, once again, how can you obtain a representative state of the soil that you are sampling? Soil characteristics are likely to vary across an area. And the larger the area and the more varying the topography, the higher these variations are expected to be. If you take just a single sample at a single point, this might not be representative for the complete field. Therefore, one common approach is to sample multiple points, for example in a grid pattern. There are different concepts like a regular grid, a triangular grid, or random patterns. And for guidance, you can, for example, refer to the international standard, the ISO 18400. Subsamples obtained in patterns can then be analyzed individually if you are interested in the spatial variation across the field, or mixed together and analyzed as a composite sample, trying to obtain a representation of the average conditions in your field. Okay, so let's start to get a bit more practical. This is a soil probe, and this is useful if you want to do regular soil sampling. It's very easy with this soil probe to get consistent samples because you will have a uniform cross-section along the depth of your soil. There are simple T-shaped models and some models like this one, which also have a footstep, which makes it a bit easier to get the soil probe into the soil. There are other tools specifically made for soil sampling, for example, augers, and the best tool depends on the soil type and your scope. A very nice overview is provided, for example, in the field book of the US National Soil Survey Center. For the topsoil sampling that we are going to show you today, the regular push-in soil probe is sufficient. But there might be situations in which you don't want to invest in specialized tools. For example, if you just have a small number of samples, or you want to take samples in your own little garden and you don't plan to take hundreds of samples every year, or you just might work with a limited budget. Another reason might be that you want to collaborate with many researchers or citizens, maybe across different research groups in different countries, and you cannot expect availability of the same tools in every place. In such cases, you can always default back to using simply available tools like this spade. This is actually done in large soil sampling campaigns like the Lucas soil sampling campaign, which has produced the biggest topsoil dataset for Europe, and where nearly 19,000 samples were collected for the 2018 campaign. So this is really just to show you that you don't necessarily need to purchase new or expensive equipment to achieve good results. Okay, so let's begin with the actual soil sampling. And we begin with the soil probe, and you can see that we marked here the 20 centimeters to which we want to sample today. It just makes it a bit easier when pushing in the soil probe. And what you can also see is that the field we are sampling today is quite overgrown, so we just removed a little bit of grass and the top litter to then actually use the soil probe here, which is quite straightforward. You really just need to push it in, and then the footstep comes in very useful. And if I'm down to the 20 centimeters like so, I can then give the soil probe a little bit of a twist, maybe quarter turn, maybe half turn, and get it back up again. So you will then have this 20 centimeter sample in the soil probe. So we can then use this sample for the analysis. So we transfer it to a bag, for example. It could be a plastic bag. Or if you want to mix a composite sample, you would now go on and follow the grid pattern or a random pattern to collect multiple subsamples, which would then be transferred to the bucket, mixed in the bucket, and then again packed into a bag or a little cardboard box maybe, for further analysis in the lab. Okay, and then I also want to show you how you can use the spade for taking a soil sample. So what we want is along the depth of 20 centimeters, we want a sample that is approximately 3 times 3 centimeters. So we want to try and also get this nice and uniform cross section. So we start by just pushing into the soil in kind of like a V shape. So once from this side and then once from this side. And after we removed this first part of the soil, what we can do now is we just go to the side and we want a slice of about 3 centimeters. So we push in, and what we will get now is hopefully a very nice and even part of this soil. And if we get this out and we have this chunk, of course, you can see I have much more than 3 centimeters here. So you then use a trowel and you want an even sample. So what we do first is from the sides, we remove about this much. So we keep only about 3 centimeters in the center. Now, this one and also this one. And as you can see, we now have a very nice and even cross-section along the depth of 20 centimeters after trimming off the sides at the spade. And with this first subsample, if we would follow the Lucas procedure, we would then take 4 more subsamples, 2 meters distance around the center point in the northeast, south, and west directions, which would then give us 5 subsamples, 1 from the center, 4 around it, which we can then mix to get the composite sample, which is still very much representative of the exact point location in the center. That's it for our introduction on soil sampling. We hope that we could give some useful tips and examples and that you feel more confident now going possibly into your very own first soil sampling. Happy soil sampling!